Firms invest millions in BIM software, expecting a seamless miracle, a building materializing perfectly on screen, instantly resolving all design conflicts. The reality on the ground looks very different. Projects stall under massive request for information backlogs, huge files crash workstations, and regulatory bodies reject the submissions outright. This friction happens because we are treating BIM like a standard two-dimensional drafting tool. It's not. A BIM model is a strict live relational database. Every line drawn is a data entry. This flowchart maps the broken pipeline. When that database is populated with bad information, the system fails. The first major symptom is misclassified data. Putting an object in the wrong category breaks the logic that downstream software relies on. The second symptom is over-modeled bloat. When designers cram unnecessary visual detail into a model, the file size balloons. Once part models push past the 800 megabyte limit enforced by platforms like CornetX, the system's simply choked. Finally, we see uncoordinated duplicates. Multiple disciplines modeling overlapping elements creates a tangled mess that only gets discovered when physical material arrives on site. The software itself isn't failing our projects. A lack of strict data governance and basic modeling discipline is failing our projects. To fix this, we had to look at the return on investment for our modeling efforts. We need to separate the inputs that actually add value from the shortcuts that actively damage the project. This ROI analysis table weighs our inputs. The first rule is governance. All stakeholders must sign a strict BIM execution plan. This eliminates double handling of work and ensures the resulting data is legally compliant for automated clash detection. There is a painful trade-off. Strict governance front-loads your timeline, delaying the gratification of 3D progress. Which brings us to the worst industry habit, forcing geometry. Designers often use the wrong software tools just to make things look visually correct. If you use a generic wall tool to draw a structural column, the model looks fine to the human eye, but the database sees a wall. That shortcut destroys your IFC plus SG mapping and corrupts your automated schedules. If you maintain strict categorization, your model achieves flawless interoperability with third-party validators, like Celibri, and your quantity takeoffs generate perfectly. The trade-off is that this slows down the individual modeler. They can no longer rely on user interface workarounds. They actually have to learn real construction taxonomy to classify elements correctly. In a BIM environment, a practitioner's primary job is data entry. The geometry is just a byproduct of good data. This leads to a constant tension. Clients often want a visually impressive model that looks like a photograph, while the site team needs a lightweight, functional tool. The rule here is strict precision. You model only the essential elements and functional clearance zones, like the empty space required around an MEP unit for maintenance. Micro details, like individual fasteners or tiny screws, must be pushed out into flat 2D drafting callouts. This restraint has a massive operational outcome. The models remain agile and lightweight. You can actually load them onto field tablets for virtual design and construction right on the active site. To remain viable, you have a hard technical ceiling. Your part models must be strictly kept under that 800 megabyte limit. The trade-off is client management. Project managers have to constantly educate their clients that a BIM model is a gritty construction tool, not a polished marketing render. This is the official BIM handover technical guide. Every unnecessary polygon you add has a processing cost. Useless geometric detail bankrupts the data's utility long before handover. There is another hidden financial danger lurking inside these complex models, the duplication trap. You cannot allow objects to overlap. If an architectural floor occupies the exact same physical space as a structural slab, the database registers both items. The mandated solution is running routine, weekly interference checks, specifically designed to hunt down and delete duplicate items across disciplines. Ignoring these duplicates leads to a disastrous financial outcome. You end up double counting materials in your automated bills of quantities. This requires dedicated overhead. You have to pay a BIM coordinator to actively police the model and enforce spatial discipline. Paying a coordinator's hourly rate to find duplicates is vastly cheaper than paying a supplier for double the concrete. These rules roll up into the single source of truth scorecard, the ultimate standard for your project's health. For architects and modelers, you cannot leave floating objects in the file or cheat categories to save time. Those individual shortcuts directly break the downstream pipeline for every single person who touches the project after you. For contractors and facility managers, you must actively use the model on site. Bring it to the field to rehearse construction and identify physical clashes before they happen. However, you cannot blindly trust the model for exact material extraction unless the BIM particular conditions explicitly guarantee that level of accuracy. The best BIM models in the world are not the prettiest. They are lightweight, meticulously categorized, and strictly governed. A true BIM model is not a rendering. It is a legally binding contract. Treat the data accordingly.